Hello, students, and welcome back to your physics buddy. We are starting a brand new essential unit, work, energy, and power, in the previous lecture. In this lecture, we'll be discussing about kinetic energy. We'll talk about what is work energy theorem. Apart from this channel has already covered different units as per the AP Physics as well as Honors Physics curriculum. In this lecture, we are kicking off with work energy theorem. Make sure you subscribe to the Honors Physics and hit this notification to follow the entire series and stay tuned. Let's do this.
So let's just do a quick recap of what we have done before. So in the previous class, we started with Unit 7, that is work, energy, and power. We simply explained that work is defined as force times displacement, or you can say how much force is acting on a particle and what displacement that particle does. So that product of force and displacement will give us work. We understood this thing that either force should be in the direction of displacement or displacement should be in the direction of force. So work is something which can be written as Fs cos theta. Again, this is a scalar quantity and this doesn't have any direction. Also, you need to understand this thing that force can also be written as F dot S. Wherever there is a cos theta, there is a dot product. So that thing also you should keep in mind. Then we discuss some cases that in which case work can be positive, work can be negative, or work can be zero. So if theta lies between 0 and 90 degree, or you can say the angle is acute, then the work is going to be positive, such that force and displacement both are in same direction. Then we talked about negative work, and negative work is something when theta must lies between 90 and 90 degrees, or you can say theta is going to be obtuse. So in that case, work is going to be negative. So I just gave you an example explaining the same condition. Suppose you are driving a car and suddenly you applies brake. So when you applies brake, car will slow down as you are applying the force in the backward direction, but still the car is going in a forward direction. So in that case, work is going to be negative. Then we talked about zero work case in which force and displacement should be at 90 degree to each other. So in that case, the work is going to be zero. Then we did several examples in which we calculated how much work is going to be done in given time. So you can just look at these examples at how we were supposed to do that. We find out different physical quantities related to each and every case. And again, this will also use equations of motion sometimes to find out displacement, sometimes velocity, and sometimes other things as well. Then we discuss some questions from the assignment sheet you shared, and you must know how we're supposed to do this. So again, the most important part here is work done by different forces will be different in different cases. We just need to understand that how that force is acting and how much displacement is being done against the force, either in the same direction or either in the opposite direction. Always remember, work done by the gravity is negative, because force due to gravity will always act opposite to the direction of displacement, means most of the cases, but sometimes it do act in the same direction as well. Then we had another example, another question from the same assignment sheet in which we discussed how much force is actually responsible for object's displacement or against the direction of object displacement. So whenever we are calculating work, sometimes we do calculate work due to net force, sometimes we do calculate work due to some specific force. Like here in this case, we calculated force work using work against the force, which is mg sine theta. So the net force is something which is responsible for the displacement, or you can say net force is something which is responsible for the work in this case. Also, always remember, whatever force is acting perpendicular to the direction of displacement will do no work, or we can say that there is going to be no work because of that force. So that is something we discussed in the previous session. In today's session, we'll start talking about energy and different aspects of energy as well. So what we need to understand here is that whatever work is being done on an object, it is going to stored in the form of energy. Work is always going to store in the form of energy. Now this energy can be of so many types. This energy can be of so many types. Majorly, we have to discuss about mechanical energy. Like how much mechanical energy an object can have if some force is doing work on it. Also, we understood this fact and we should know about this thing that mechanical energy is of two types. One is kinetic energy and another is potential energy. So in today's session, we're going to talk about these two types of energy in detail. We'll also understand that what are the expressions of these two types of energies, as well as we'll understand that how this energy can be calculated. Apart from this, we'll talk about work energy theorem. Work energy theorem simply gives us this thing that whatever force is acting on an object, that force does some work. Due to that work, we can simply say that the total work which is done on the object is always equals to change in kinetic energy. This is what work energy theorem says. So we'll talk about it, we'll prove it as well. But before that, let us talk first about what is kinetic energy. So in the earlier grades, you must have learnt about kinetic energy, or you can say kinetic energy is the energy which is associated with the motion of the body, or I can write it as the energy associated with motion of an object is something we call kinetic energy. Whereas whenever we're talking about potential energy, so this is that form of energy which is associated with either we can say configuration, we can say position of the given object. So this is the major difference between these two. Let us try to understand about these two types of energy in detail. So as I told you that whenever we are talking about energy, so that energy which an object possesses is always due to some force acting on an object. So let us just try to understand this thing. Suppose there was an object of certain mass which was initially at rest. Now what happens here is just applied some force from the backward direction such that this object at certain point of time moving with some velocity v. So this is the velocity with which the object was moving because of the application of force. Or you can understand this thing by this fact that whenever a force acts on an object, it not actually not only displaces the object, but also because of that force, the object will gain some velocity, and that velocity is responsible, or you can say that velocity is the result of application of force. Now, if we try to calculate work in this case, we know work is always force times displacement. Now, if we try to write the value of force here, as the force acting here is a constant force, we'll assume that there is some constant force acting on the object. So we can also write force as mass times acceleration. If we try to substitute the value of this thing, as, we can say acceleration times displacement, using equations of motion. So we are going to have, so using third equation of motion, we can say that final velocity square minus initial velocity square must be equals to 2 times acceleration times displacement. So final velocity is something which is v, initial velocity is something which is 0. It is equals to 2 times a times s. So from here, if we try to find out the value of as, we are going to have v square over 2. So we'll simply substitute the value of as here, which we can write it as v square over 2. So from here, we'll have work done as half mv square. This work done is something which is converted or represented by the kinetic energy of the body, which can be written as half mv square. So this is the basic relation or generalized relation for kinetic energy. What you need to understand here is that whatever work is done on an object, it cause change in its energy. This energy can be of any type, whether it is kinetic or whether it is potential. We need to understand that it is going to change its mechanical energy, to be precise. Mechanical energy is something which is associated with object's position, configuration, motion as a whole. So whatever work is going to be done on an object due to some external force, that force is capable of changing the energy of the given state. So here we simply saw that if an object was initially at rest, we applied some force and that to a constant force. So that force actually not changes its position, but also it changes its energy. As after a certain point of time, it got some velocity. So kinetic energy is something which can be written as half mv square. Again, if we talk about it, it is again a scalar quantity which doesn't changes, which doesn't have any direction. Apart from this, it has unit same as that of work done, which is joules. So energy, work, they both have same units. That is what we need to understand. They both have same nature, that is scalar. And kinetic energy is something which is associated with the motion. So if an object is in motion, or you can say if an object is moving with certain velocity and that too a constant velocity, we can simply say that the object must possess kinetic energy. That is the most basic part about kinetic energy. Now, what we need to understand here is, apart from all these things, this force need to be constant, or if this force is variable, in that case work is going to be variable, or we cannot have kinetic energy a constant thing, because it will change as the force will change. Apart, maybe with a function of time, maybe with a function of displacement, it can be of like anything. Let me just give you a little idea about for variable force. So for variable force, things are going to be a little different. Now this variable force can be variable in two things, in two ways. Either it is variable as a function of time, or either it is variable as a function of displacement or position. Like for example, suppose the equation of force is given as, it is a function of time, I'm assuming. So it is given as 3t square plus 4t plus 2. So this is the equation of force which is variable, and it is representing that it is changing as time changes. Similarly, if force is a function of position, we can have the same situation here as well. This is also the equation of force having the same units Newton, but we need to understand this fact that in both the cases, force is variable as a function of time and then as a function of displacement. So this will change the whole thing, and because of this, work done is calculated as f dot dx, that to integration of it. So I know we don't have to go into it, but yeah, we need to keep this thing in mind. Because of this, whatever kinetic energy we are supposed to have, this is also a function of force in terms of displacement or in terms of time. So we have to write it accordingly. Uh, no problem will be there as far as your syllabus is concerned, but yeah, conceptual questions must be asked based upon this fact that what if the force is variable. Apart from this, there is another thing that we can learn from this particular fact. Suppose if we are given with force and displacement graph, if we are given with force and displacement curve, in that case, work is simply calculated by area under the graph. Area under the graph. And this thing can also be written as kinetic energy of the given system must be equals to area under the Fs curve. So these are the things that we can keep in mind here in case if we have some problem associated with graphs. Like for example, suppose this is a graph which has force and displacement acting, force and displacement representing by x and y axis respectively. So whatever graph we have, let's say force and displacement varies like that. So in that case, if we have to find out the work done, what we can simply do, we can simply find out the area of the given situation. You just have to find out how much area is there, and that area is equals to either work done or equals to either kinetic energy. So that is another thing that you can keep in your mind regarding the work and kinetic energy. Apart from this, let us try to solve one problem associated with kinetic energy thing only. So question says a body of mass 40 kg initially at rest experiences a force of 100 Newton such that it displaces 200 meters in some time. Question is find its kinetic energy at the end of 200 meters.
Okay.
So how are we supposed to solve this question? First of all, we have to find out that what should be the velocity of the body when it has moved 200 meters. Whatever velocity we'll have,
Mm,
we simply put the value in the relation of kinetic energy, which is half mv square, and we can have the kinetic energy at this particular point. So mass is given as 40 kg. The force acting on the system is 100 newtons. So you can use equations of motion as well to find out the velocity later on. So I guess you can do it. Try it out.
okay. Is it 20,000 joules?
Let's check it out. So first of all, we have to find out the final velocity. And in order to find out the final velocity, we need to have acceleration first. So acceleration in this case is going to be force over mass, which is going to be 2.5 meters per second square. Final velocity is something which can be written as v square. V final square minus v initial square is equal to root twice of acceleration times displacement. So which is 2 times a times 200. So we got v square as 5, or you can say 1000. Now kinetic energy is going to be half mv square. Now we can simply substitute the values. Mass is 40, v square is 1000. So we're going to have 20,000 joules. Yeah, your answer is correct. A
I just
pretty simple one.
multiplied 100 times 200
100 times 200. Why?
because work equals um, force times distance. I mean, not distance, displacement.
Yeah, you can do that as well.
Okay,
Nice. Yes, you can do that as well because we know work is nothing but force times displacement, and in that case, kinetic energy is also going to be same. So you can also do that 100 times 200, which is going to be 20,000 joules once again.
right.
You can apply this relation in this case, but not
But you
in
should
the
use
case.
this one in any like every case. The one you said.
Yeah, yeah, you can use it. But sometimes you cannot do that. Let me
Okay.
give you another question. So question says the body was initially moving.
Wait, the only reason why I could use this one is because it started from rest, right?
Yeah, that is
Oh,
the case. You used it. So body initially moving with 5 meters per second, let's say, having mass 20 kgs, such that a constant force of certain magnitude acts on it such that it changes its velocity to 15 meters per second during 10 seconds. Find force acting on it. Second thing, displacement during that interval. Third thing is work done by that force. Fourth thing is change in kinetic energy. Now try this one out.
Okay. Okay, for part one, I got 20 newtons.
Okay. Yeah, correct.
Okay.
So we can write force as mass times acceleration, and in
Yeah.
this case, acceleration can be calculated using the first equation of motion. Everything is given here. You can simply substitute the values and you can get the value as 20 newtons. Right. Second one,
Yeah, I'm doing it.
you can simply use equations of motion.
Yep. Okay, I use the second equation of motion and got 100 meters.
All right. I can simply find out work as well, which is going to be 2000 by simply multiplying
Yeah, 2000.
force and displacement. Fourth part, what is change in kinetic energy?
Mm, so the kinetic energy formula and then 2 to the power 10 times 2 is 2000.
Let's check it out. So change in kinetic energy is simply, you can say final kinetic energy minus initial kinetic energy.
Yeah.
Final is going to be half mv final square minus half m v initial square. It is equals to half. You can take m common, and v final square is 15 square minus 5 square, which is equals to mass is given as 20 kgs. So it is going to be 225 minus 25. It is approximately 200. Once you solve this, you'll have kinetic energy as well, 2000 joules. Now, when you're solving MCQs, you don't have to actually do this. You simply found that work is going to be 2000 joules. Change in kinetic energy is also going to be the same, because whatever work is going to done by that force, that
Oh,
work is actually going to produce the same change in kinetic energy.
right.
So you can actually answer the same question by simply just looking at the values here. That's it. This is how you have to do this.
Okay.
So I'm just looking at some of the problems you shared in the previous assignment, like the assignment sheet. If you just look at it, question number 54, 55, 56. You should try 56th question.
Or
Yeah, so basically the combined mass is given as 45 kgs. So on ride his bike 1.80 kilometers in 10 minutes
50s. Okay.
at a constant velocity. Find out its kinetic energy. Yeah, pretty simple, I guess. You can do this.
Right. Okay, velocity is 3 meters per second, and then you just substitute into kinetic energy formula.
Yeah. So you
That's one
simply have to do
option.
this.
Mhm. Oh,
So you'll be getting 202.5 joules. That's it.
okay.
All right. So let's just talk about potential energy now. So potential energy, as again I said, it is something which is associated with the configuration or the position of an object. What does it actually mean? Let us try to understand it. So sometimes when a force acts on an object, it changes its position with respect to the initial coordinate. Like for example, suppose there was an object kept at this point. We just push this object in such a way that it reached a certain height. So during that change in its position, what we generally observe here is that throughout the motion, there is a force must be acting, that is its weight, in the downward direction. So when this force acts in the downward direction, the displacement is done in two different directions. Or we can say the displacement which is done along the plane must have two components. One is along the horizontal line, another is along the vertical line. What we need to understand here is that this displacement has two components. One is going to be s cos theta, if I assume that the inclination is theta. Another is s sine theta, which is opposite to the direction of force acting here, that is mg. We need to understand this thing that work is going to be zero for this component of displacement.
Mm.
Yeah. So I was saying that this component of displacement, that is s cos theta, is not going to play any role in actually doing the work, because this force which is acting on the object is acting perpendicular to the surface. Like whatever surface we have, this force is acting perpendicular to the surface. So whenever we are calculating work due to this mg needs to be acting in such a way that there is a displacement either in the direction of force or either in the opposite direction of force. So here this s sine theta, or you can say, if I assume that there is some displacement in the vertical direction which is given as h, so the work here can be simply written as force times displacement as usual times cos of angle between force and displacement.